We just did stoichiometry at STP. This is stoichiometry because, let's face it, we're not at STP when we're in the lab. So we have to know how to do problems that are not at STP, at non-standard conditions. That's what we kind of had with the density one we did with the butane lighter. Only I had you do that using the old method of the combined gas law, V2P, 2T2, that stuff. This time I'm going to show you how to do stoichiometry at non-standard conditions, and we're going to, instead of using the gas law, the combined gas law, we're going to use the ideal gas law with the stoichiometry. It's going to make the problem considerably longer, all right, but not really that much harder. Only one step is different, as you'll see. Okay, copy this question now. And you see, this would be the exact same kind of problem I could have asked you last period if I just changed these last few words. If I just said, instead of this, it said at STP, it would be the same problem, okay? But it doesn't. So that's the problem.
You like your job?
Yes, I do.
Do you?
As he says that with a smug face.
Yes, I do.
And think about it.
No, I didn't.
It could be worse. It could be worse.
It could be
Garbage
worse.
man.
Are they selling lollipops in this Christian's room?
Go find out.
Are we just
Probably.
asking random questions now?
Yeah,
I
are
think
selling
they are.
lollipops.
They are. Okay.
All right. Now look at it.
Jerry,
What?
you ruined it.
I know. That's
If you look at this question, it's just like the last one. I'm going to have to read it several times. The first question I'm going to ask myself, what's the equation? What words tell me about the equation? If you're not following this, guys, look at. You realize we've been doing this before Christmas. We first got it, and then we took a little bit of a break. We came back after Christmas. We did all the gas law stuff, but now we're back to it. You know, it should be like second nature by now. Decomposition of aluminum carbonate. Now I'm going to shorten this up again, like the last one, especially this one because I really need more room here. So I'm going to just write the formula for aluminum carbonate. Al with a +3 carbonate with a -2 is going to be Al2CO33. It's going to decompose into, look at your common ion sheet. What does it break up into?
AlCO plus oxygen.
Aluminum, no.
Oxide. Aluminum oxide and carbon dioxide.
Aluminum oxide, Al with a +3, O with a -2, 2 and 3, plus carbon dioxide, CO2. All right? So there's your first step. I'm not quite finished with it. I got to balance it. Well, how am I going to balance this equation? Put a 3 in front of the carbon dioxide. All right. Well, that's the same way you would have done. You just finished the worksheet. Same way you would have done that one. Okay. Same way you're going to do the next step. I'm going to look back up there. What starts off my conversions? 2.18 grams of aluminum carbonate. Okay. So I'm going to write that down. 2.18 grams of Al2CO3. Now, don't worry about getting your calculator out at this point, because that will be a pain in the neck to do, all right, when we go to do the molar mass of that guy. But you know what to do. What units have to go on the bottom here? Grams of aluminum carbonate and moles of aluminum carbonate on top. Right? 1 mole contains how many grams? Well, I've got that worked out for you, so you don't have to look it up. It's 233 point something. Let me see. 233.99, I think. Approximately. All right, it's not important, it's exact, because, you know, what is important, I do want to take a few seconds. I don't want to have to make you do it, but how would I have done it? How many O's would I have had to add up? Not 3, 9. 3 times 3 is 9. How many C's? 3. How many L's? 2. You have to add them all up and show me the work for that. Okay, now, that's nice. Grams cancel. Nothing different here. Moles are going to go on the bottom. Moles of Al2CO3, 3. I look up one more time. These are the exact same steps. I'm looking for carbon dioxide, so I put moles of carbon dioxide on the top. I fill them in with the correct coefficients. Coefficient of carbon dioxide is a 3. This guy's a 1. But do not start your next one. Let me show you why. Do not write what I'm about to write down. I'm going to put it in red to remind you of that. I could, you might think, I could just do this. All right, I'm almost there. Moles in the bottom of CO2. I need volume, liters in the top of CO2, 22.41. Be nice if I could do that, but I can't. I can't do that because 22.4 is only at STP, and we are not at STP. So I got a problem. Let me erase that guy. Here's what I'm going to do. I'm going to stop right there, and I'm just going to get my answer. Do all this and get your answer in moles, and I'll tell you what we're going to do with that in a second. Do the math for that. Get your answers in moles of carbon dioxide. If this question had simply asked for moles, you'd be done at this point if it didn't want volume. I believe it's 0.0279. Is that what you got?
Yeah.
0.0279 moles. Y'all got that? Or something like that? Close to that? I hope.
No.
Good. If Emily didn't get it, it means it's probably right. All right, everybody get that though? Really? Yeah? All right. Now, anybody figure out what I can do now? Well, let's look what I've got, and let's look what I'm looking for. I'm looking for a volume. I know moles, pressure, and temperature.
I don't want to do that.
Yeah. We're just going to use PV equals nRT. Yay. And there was much rejoicing.
That was really.
Mhm. You guys have been watching Walking Dead too much. Sounded like a bunch of zombies.
Watch that twice.
Prison break's the way to go.
All right, pressure. Now, again, I got all the same changes I got to make to do this problem as if I was doing it last week. 992 torr is no good. I have to have it in atmospheres. Torr on the bottom, atmospheres on the top. 1 atmosphere contains 760 torr. Do the math for that. What do you get? What'd you get? Let me get that. Everybody got 1 point? You said 3.1 atmospheres? All right. What's my volume? It's what we're looking for. It says determine the volume. All right, it's my unknown. What's my moles? How many moles do I have? Yeah, we went through this whole big problem to get the moles, 0.0279. R, of course, is a constant, so it doesn't change, 0.0821 liter atmospheres per mole Kelvin. And my temperature?
297 degrees.
Yeah, because it's 24 degrees Celsius plus 273 is 297 Kelvin. Okay? All right. I'm solving for V. My equation is PV equals nRT. What will I do to both sides? Divide by P. P cancels. I get V equals nRT over P, which would be 0.0279 moles. Keeping my units, you'll see they'll come out right. 0.0821 liter atmospheres per mole Kelvin. And your T is 297 Kelvin. All over
2.8.
1.31 atmospheres.
Awful experience.
I don't even remember what it is.
Are we doing any more of these problems after
No, I'm only doing one example of this one because it does take a little longer. And I want you, again, I'm going to collect this worksheet at the end of the period. Do the math for this. What do you get?
3,000.
How much? It's not 3,000.
That's not what I was.
What is it?
0.5.
0.52, something like that? 0.519, you said?
Yeah.
And let's take a look at our units. Atmospheres, they cancel. Moles cancel. Kelvin cancels. Only thing that doesn't is liters. I would expect to get my volume in liters, and I do. Okay? Now, before I leave this guy, let me say a couple things. All right? This is exactly like the kind of problem we're going to get in lab on Monday when we do the lab. All right? It's going to be done exactly the same way. you're going to have to do a stoichiometry problem and then an ideal gas law problem together. All right. There is another way I could do these. I'm going to show you that probably on Tuesday as part of it's you know there's a I could do it in the beginning versus at the end. I'll talk about that on Tuesday a little bit, have a review, and Wednesday will be the test most likely. Look at that problem. Look at all that's involved in that. Pretty much everything we learned, everything you learned, it led up to stoichiometry, and then pretty much all that you needed to know about gas laws and gases. It's pretty impressive. You should be impressed.
How many problems are